Now you're about to learn how to prepare your model before starting MWF like a pro. In this video, I'd like to share my 3 years experience working with framing detailing and how to get the most out of the plugin while maintaining the excellent quality. Why do we need to prepare our model? Model preparation is one of the most important aspects of our approach to any project. The architectural model that we have is not ready for the framing population, and if we proceed with the MWF work with the unprepared model, we will spend a significant amount of time repairing difficulties that occur. We carry out model preparation to reduce the amount of time spent working with the plugin, as well as to minimize difficulties and rework, while regenerating each individual panel. I'd rather spend 1 day identifying any model flaws or inaccuracies than start the MWF and let it perform the rest of the job. Then, step-by-step instruction on what to do in model preparation. The first step is to ensure that everything is in accordance with the design. Sometimes, the architectural model is outdated compared to the drawing set. Therefore, we must go over the model and ensure that all grid lines are accurately placed and that the types and location of walls, doors and windows match the drawing set. The issue can occur when the model is more up-to-date than the contract documents, in which case we must contact the project manager and choose which should be followed, model or drawings. After we determine that the model is built according to the drawings, we must check the wall joints. Looking at the plan view, we can see that many of the walls are not connected properly. Some of them are disjointed, so one of the first things we do is walk over the floor layout and inspect the wall connections. Also, the drawings provide the corner and T-intersection configuration, so we can identify particular cases where we should dissolve join in wall connections. For example, in this case, the intersection wall is too close to the door, and the MWF joint is most likely will not be placed properly here, so we disjoint this wall. The next step is to check the wall height. The architectural model is mainly used for drawings. Therefore, the wall height may be inaccurate. Also, some walls may have different top constraint that the design indicates. For example, we always cut walls that are attached to the steel beam. There are many structural details that reveal clips to attach the wall to the beam, and we lower our walls before running the MWF process to ensure the wall height is correct from the start. When all of the walls are done, we can go on to the ceiling and check the type and height to ensure that the drawing set is followed. We also inspect the ceiling structure to ensure that it is in accordance with the drawings and the right ceiling joists are placed. Another key aspect of the MWF is the single profile in one ceiling. Thus, we are examining and adjusting the correct ceiling profile because sometimes the architectural model has multiple profiles in one ceiling. We even created a script for splitting them into several profiles automatically. The last and crucial phase in model preparation is to include soffit details. I didn't see an architectural model that contains all of them. So now we'll move on to the most interesting step in the model preparation: creating soffit details. We look through all of the ceiling design, select the soffit details and include it in our model. Attention and precision are required here, since the soffit wall must be attached to the ceiling as shown on the design, sometimes using gypsum board and sometimes structure to structure. I worked on a lot of projects that required challenging soffit configuration. In addition to the soffit, there are many particular elements surrounding entryways, canopies, and outside walls that need complex construction. We also consider these details while designing the vertical walls and horizontal ceilings. Here we go to our tips for model preparation. This is described the model preparation process, but we also have a few tips to help us get things done faster. For example, we create filters based on the fire rating of walls because some of them must be connected through gypsum board, and it is sometimes simpler to disjoin them than to develop a new joining rule. One more other tip is that we include comments on the elements. For example, if the door or window expects a specific header, we provide a comment with the name of that header so that the guy who will be working with the plugin can simply make a schedule, select all openings with that comments and apply the same opening type. Same as for the kicker details. We added the comment kicker to the soffit walls so that we wouldn't have to seek them out while working with MWF. Don't forget to do this when starting the plugin. The model preparation has been completed. and we can get to work with MWF. There are various steps that must be taken before launching MWF templates and framing creation. First of all, put the like button below this video and subscribe to our channel. Done? So let's move forward. Firstly, we ensure that all of the doors are properly working with the plugin. The framing must be installed at the rough opening dimensions, which often turn out incorrect in the income door families. So we are dealing with the door families in order for the MWF to work with them as we wish. Additionally, clash detection with structural beams should be performed in order to construct all beam pockets. Even with the link, MWF clashes with it, but only if the linked model's coordinates are set. And then you can start creating framing. These steps is helping us to avoid rework working with MWF and reduce the number of issues that may arise. I shared with you our model preparation process and the ideas we utilize. Text in the comment if you disagree, believe it is redundant or have something to add. Don't forget to follow us on YouTube for additional behind-the-scenes video and updates. Take care!